At first, the large number of tools and options available in Artec Studio can seem a bit overwhelming, but there's a basic workflow you can follow no matter what object you're trying to capture and reproduce within Artec Studio. If you'd like to follow along with what I'm doing, check the video description. There should be a link to a PDF guide that walks you step by step from start to finish, everything we're going to do here, but also underneath each step lists a bunch of details and tips and tricks and specific numbers that you need to know along the way. So that's a very helpful guide. You can also check the video description for a link to the actual data that we're going to create here. So you can open that up in Artec Studio and follow along. All right, let's get going. Switch over to my software here. I will be scanning this little propeller. It's a nice, simple mechanical object. I will be scanning with the Artec Space Spider, although everything I'm doing here also applies to pretty much any other scanner that you use within Artec Studio. All right, so I'm going to capture my data. You'll notice if you've done any scanning with different scan options within Artec Studio, I don't have the automatic base removal enabled right now. The reason for that is that that's not great for every object out there, and I want to show you start to finish each individual step that you might follow no matter what you're trying to scan. All right, so I've flipped this over and I am now capturing data on the other side of this propeller so that I can have a complete object. And there we go. All right, so I've captured my data. Let me switch my cameras here. Okay, so I have my data. You'll notice over in my workspace on the right-hand side, I have two separate scans. And as I'm going through this, step by step, whenever I want an algorithm to affect, or an algorithm or a tool, such as the eraser tool, which we're about to go into, whatever I want to have affected by that, you have to make sure your scan is active. So if I want to affect both scans at the same time, I would have them both affected. I only want to erase from one scan at a time, so I'll just make sure that one of these is selected. And I'm going to click the Editor tab here. Now, after you're done scanning, when you first leave the Scan tab, it's going to automatically run fine registration on your scans. All right, so I'm over here in my Editor tab. I'm going to click the Eraser. And there's several different eraser options here. I'm not going to go into depth for each of these, but there are different tools depending on what you're trying to erase. For this one, I'm going to use this cutoff plane to come in and select a little bit of my base. And you can move this plane up and down. I'm going to click Erase, and I've now erased that base. Again, I'm going to use cutoff plane selection. If you want to know how to use these tools, there's some little notes up here in the top left-hand corner that show you exactly what to do there. All right, so I've erased that. It could be that you have other things that were in the scanner field of view as you were scanning that you might want to erase right now. So you would want to remove anything that you don't want in your final scan or in your final fused scan or the resulting mesh. So I don't have anything else right here that I need to get rid of other than the base. So I'm done with that. After erasing whatever you don't need, you can move on to the alignment step. So I'm going to close my eraser and click Align. Again, I made sure that both of my scans were active because I want to use both of those. Now, we're working with a mechanical object here, and mechanical objects are very smooth. They don't have to be, but a lot of mechanical objects are very smooth, symmetrical, that sort of thing. So the auto alignment may not work well. I know it won't work well for this one, but I'll show you what happens. If I click auto alignment, it will either say that it failed to align the scans, or it'll try its best, and you might get something like this. That's not a big deal. That's just auto alignment. It works really great for some things and not so much for others. So the manual process, though, is always available. And some people, when they hear manual, they think, that it's going to be a really difficult process, but it's not. all that involves is I'm going to visually line these up, and I don't have to be perfect here. I just want to get things close so that I can click 3 common points on each scan to give the alignment algorithms kind of a starting point. So I actually did make some marks on here so that it makes it a little easier on myself when I'm clicking points to align. You can do that with your objects as well, or use things that are already on the object. So I'm just going to click like that. All right, so I clicked 3 common points. I'm going to click Align. All right, and that looks pretty good to me. All right, so manual alignment was successful. The next step is to click Apply, and then you can move on to your Tools tab. So now that everything is lined up, ready to go, we're going to go through and actually process the data to create something that, a uniform surface that could be exported as a point cloud or a mesh. The first thing I'm going to run is global registration, and you can leave this at the default for most scans. There's some notes in that guide on that, but I do want to mention that if you do change something in any of these algorithms, you'll notice that it goes from an empty box to a filled box. And if you don't remember what the default was, you can always click that filled box to set it back to the default. That's a nice helpful tip there as you're working with the algorithms. All right, so I'm going to click Apply. And global registration looks at all the individual frames that were captured in each scan and make sure that everything's lined up across all scans. It's like a fine-tuned final alignment of everything that was captured. All right, so after that, we're going to move on to outlier removal. Now that global registration is complete, I can actually come over here and look at my max error column here. And there are some notes in that PDF guide, but for the space spider, you want to see something between 0.1 and 0.3. And then, as I said, there are some notes in that PDF guide that go into a little more depth about that. But you don't actually look at this value until after running global registration. Now, this value is important because when I come down here to things like outlier removal and have to choose a resolution, the resolution in these fields can never be lower than whatever number is here. So I wouldn't want to run this at 0.1. I would want to run this at 0.2 at the minimum, but I'm going to run this one at 0.3 millimeters is what this resolution value is. And these settings are fine. They're not the default, but this is what I'm going to use for this. I'm going to click Apply. And with the outlier removal, whatever resolution I choose there, I want it to be the same as whatever I plan to run my fusion at, which is the next step. So that outlier removal, I don't know if you noticed, but if I do Control-Z to undo, you notice all these floating points and stuff. Outlier removal removes a lot of that noise. Makes just for cleaner data. And that's used mostly for Artec Space Spider scans, although it can be used for EVA scans sometimes in some cases. All right, so the next thing I'm going to do is run a fusion. Fusion takes all these individual frames that were captured and merges them all together. So I will come down here. I will expand my sharp fusion option. I'm going to look at my resolution of 0.3. That's fine for what we're doing here. I'm going to choose watertight for the hole filling. What that will do is fill in all holes completely and give me a watertight mesh, which, if you're not familiar with the term watertight, that's what is required for 3D printing and certain other processes, right? You have to have a mesh that is completely enclosed with no holes in it. Now, if I only had a single scan with a large hole in the back and I didn't want to fill that in, then I would probably want to run the hole filling by radius, and then it would just take care of the small holes. But I'm going to choose watertight, 0.3 millimeter resolution, click Apply, and we will let that run. And again, it's just fusing all of those individual frames into a single model. All right, so here is our model. That looks really good to me. Now, After running that, you end up with this fusion over here in this workspace. If I double click on that fusion, I can see that it is made up of about 330,000 polygons. That might be fine for whatever program that you're going to bring this mesh into, but it might be too much. Again, depending on the program. That's nothing for some, but others it's extremely heavy. So I can come down here to, sorry, I almost skipped a step. We're going to run small objects filter after you do a fusion. What that does is it takes care of any disconnected pieces, even if you can't see them, it takes care of any disconnected pieces in the mesh. All right, now I can run over to my mesh simplification, which I'm going to run fast mesh simplification just as an example and say 200,000 polygons. But if you're reducing and you want to keep as much accuracy as possible, you can use regular mesh simplification, use the accuracy stop condition, and put in your acceptable deviation right there, and that's in millimeters. But fast mesh simplification is fine for what we're doing here. I ran that. Now if I look at my mesh again by double-clicking on that fusion, I'm at 200,000 polygons. All right, so once I'm done with that step, we could come over to the hole filling option. If there were holes, if you chose to process just a partial scan, you may want to come into the hole filling tab, and that'll let you smooth edges and fill in holes and stuff like that. But we chose watertight. All that's done already for us, so we don't have to worry about that. I could export from here if I don't care about color, but the next step, if you do want color, is to go to your texture tab. And I'm going to make sure my fusion that I want to apply color to is selected. I'm going to select both my raw scans here. That'll pull color data from both of those. If I only wanted to use one, I could, but then I wouldn't have color all the way around since it wasn't able to see the bottom on my first scan. And then I'm going to use these options right here. These are all the defaults, and they work for most things. You can change these if you want. If you want a higher resolution, lower resolution, resulting JPEG when you export as an OBJ or something like that, you could change those, but I'm going to leave that just like it is. And it is going to take all of that, all the color frames that it captured in the raw data, and reapply it over top of the mesh. All right, so here it is. I got the writing on the side, and that was a little confusing because my mesh was already kind of like a grayish color anyway. But here you have all the scrapes and stuff on this object. And what we're looking at here is a little screen where you can adjust your brightness and other settings here, but Artec Studio automatically adjusts this to what it thinks it should be. It's a good starting point. Click Apply, and then we're done. From here, we can do File, Export Meshes, and we can put that as an STL, OBJ, WRL. There's a bunch of different formats you could export as. And that's it. That is the manual processing within Artec Studio.